Welcome to the Explainer. So let's dive right in. Because what we're looking at today is, honestly, it's pretty profound. We usually just think of biological life as this fixed condition, right? Like you're either alive or you're not. But what if we completely flip that on its head? What if life is actually an active, ongoing, and literally mathematically precise struggle against entropy? Today we're exploring a fascinating concept called the razor's edge, the attractor landscape of life and death. We're going to break down the actual mechanics of how living systems build complexity, how they keep that delicate balance, and ultimately how the whole thing eventually collapses.
Think about this quote for a second. Life is not a static state. Life is a trajectory. Just wow. That is such a powerful way to reframe our existence. From the exact moment of conception all the way down to your final breath, an organism is constantly climbing. It pushes itself upward into this highly precarious zone of possibility, and literally, its entire biological purpose is to fight tooth and nail to stay in that zone for as long as humanly possible. It's just a constant, exhausting, energetic climb.
And you know what? That precarious zone actually has a name. It's called criticality. This is that exact balance point, the razor's edge where a living system can actually survive. Think of it kind of like walking a tightrope. On one side, you've got rigid order, just totally frozen, and on the other side, runaway, chaotic disorder. Life absolutely has to remain perfectly balanced right there in the middle to stay flexible enough to adapt to whatever the environment throws at it, without becoming so chaotic that it just falls apart.
These two states really highlight the incredibly high stakes of living on that razor's edge. If a system becomes subcritical, well, it's just too ordered. Activity essentially dies out into silence. The system might be perfectly stable, like a frozen block of ice, but it can't respond to anything. It's way too rigid. But on the flip side, if the system goes supercritical, activity just cascades completely out of control. Sure, it's incredibly active, but it's lost all of its structural order. A living system literally has to survive right in the narrow gap between these two extremes.
Section 1. Biology's first digital twin.
Now, what's genuinely wild is how our biology actually pulls off this incredible balancing act. When we hear the phrase digital twin these days, we instantly think of tech, right? Some big company building a software mirror of a factory or a robot to predict when it'll break down. But here's the thing, biology invented this exact principle first. Every living system is running an internal twin of itself, an HSML digital twin. It's basically a phase space representation that is constantly transacting information with your physical body. It knows exactly where your biological system is, what state it's heading toward, and crucially, it calculates whether the next move is actually worth the energy to make a correction.
So you might be wondering, where does this twin actually live? Well, the foundational blueprint of this twin is your genome. It acts like a compressed map of your entire developmental landscape, and it's executed by things called gene regulatory networks, or GRNs. Basically, what this means is that as you develop, a cell's fate isn't just picked randomly off a menu. Instead, it crystallizes as a stable attractor in gene expression space. The system naturally falls into these stable, predefined pockets of possibility.
Section 2. Navigating the attractor landscape.
All right, let's scale this up to the macro level, moving from the genome up to the brain. Because these attractors, they don't just build our physical organs, they build our conscious minds too. The really key point here is that development is essentially just a sequence of crossing thresholds, where new emergence happens at every single level. Just think about how the cortex is structured. It isn't just a stack of isolated processors. It's a deeply nested hierarchy of attractor landscapes. Step 1, columns form within localized areas. Step 2, those areas stabilize within larger networks. And step 3, those networks coordinate across entire brain hemispheres. Every single level has its own unique threshold for emergence.
And that specific threshold of emergence, it actually has a name, the B2 threshold. Let's completely demystify this. B2 is the crucial point where the macroscopic information rate, or MIR, gets high enough to basically upgrade the whole system. Before hitting B2, the system is stuck in what's called a limit cycle. It's periodic, it's predictable, it's really just repeating a bounded, boring loop. But once it crosses that B2 threshold, boom, the system enters a strange attractor. It's still bounded, sure, but it becomes fractal. It is suddenly rich in long-range correlation, and out of nowhere, it is capable of true complex immersion. And your brain is repeating this exact same attractor logic at millisecond speeds. So what does that actually look like for you and me? Well, a perception, that's an attractor. A memory you just recalled, also an attractor. A decision you're making right now? Yep, an attractor. Our entire conscious reality is literally built out of these nested threshold crossings. A conscious state is essentially just one massive, strange attractor that is being collectively inhabited by all these lower-level neural attractors firing away at once.
Section 3. The hypothalamic origin point.
Now, all of this high-minded, incredibly complex brain activity, it absolutely needs a physical anchor. It can't just float around in the ether. Let's zoom all the way into the deep, deep biology that tethers our consciousness to actual physical survival. The hypothalamus is so fascinating because it isn't the most advanced part of the brain, right? It's not the richest information processor, but it is the deepest reference point. It anchors all our baseline needs: hunger, thirst, temperature, sleep. Every single time your brain takes a massive excursion into complex thought or imagination or deep emotion, it eventually has to return back to the hypothalamus to answer one really fundamental question. Can this physical body actually keep going? It is the absolute phase-space origin of the entire organism.
Section 4. Homeostasis and the omega curve. You know, we usually learn about homeostasis in high school biology as this sort of boring, static biological chore, like a thermostat. But as we're about to see, it is actually an active, twin-guided fight to stay right on that razor's edge. Let's step through the real mechanism of homeostasis together. Step 1. Your body detects a perturbation. Maybe it's a sudden drop in temperature or a huge spike in stress. Step 2. Your internal biological state, which we call omega, starts drifting dangerously away from that critical threshold. Step 3. Your internal digital twin spots this deviation and instantly calculates exactly what it's going to take to fix it. And Step 4, a swift correction is made, literally yanking your system back from the brink of chaos and returning you to criticality. It's a constant, highly dynamic rescue mission playing out inside you every single second.
And this brilliantly illustrates how we should really be defining health and disease, at least according to the source material. It's purely about your twin's ability to actually execute those corrections. Think about it. Health is simply your system's ability to return to that B2 threshold, that absolute sweet spot of criticality right after you experience a perturbation. Disease, on the flip side, is when a drift or a bifurcation happens that your internal twin just can't correct anymore. You get stuck permanently outside the critical zone.
So when you zoom way out, you can actually trace this grand hero's journey across an entire lifespan as an omega trajectory curve. Right at conception, gene attractors crystallize, and your complexity starts its massive rise. Through infancy, all those attractor layers multiply, they coordinate, and then you hit peak vitality. This is where your system beautifully sustains criticality, extracting the maximum adaptive information for literally every single joule of energy spent. But then, well, aging begins. Those homeostatic rescue loops, they start to weaken. Your set points start to drift. The attractor basins physically flatten out, which means recovering from stress takes way longer, and it costs a whole lot more energy.
Section 5. The final thermodynamic silence. And inevitably, that increasingly expensive decline leads to an end. But the source frames death not just as a sudden mechanical stop, but as something deeply systemic. Mortality is defined here as the terminal loss of twin corrective capacity. Death arises when your biological set points drift so far from that hypothalamic origin we talked about that your internal twin simply loses the power to return the system to criticality. The organism just can't make the climb anymore. This concept actually perfectly explains a truly fascinating phenomenon we often see in the dying brain. Sometimes there's this final, massive surge of brain activity right at the very end. But the source clarifies that this is what they call a supercritical flare. Because the internal twin's inhibitory control mechanisms have completely collapsed, activity just cascades entirely out of control. It's really important to understand, this isn't a sudden, miraculous return of life. It is the catastrophic loss of order. And here are the final mechanical steps of that collapse. Step 1. The macroscopic information rate and the omega trajectory just completely plummet. Step 2. Chaos entropy, which is the measure of the system's dynamic complexity, tends towards 0. Step 3. That beautiful, intricate, strange attractor that held all of your conscious states simply dissolves. And Step 4. The physical phase space completely contracts and the system settles into permanent thermodynamic equilibrium. All that complexity totally unravels.
I want to share this direct quote from the source because it just perfectly encapsulates this tragic yet completely awe-inspiring finale. Information is not lost into chaos as a destination. Chaos is only the path of collapse. Silence is the destination. Wow. It's such a profound reminder that a living system spends its entire vibrant existence fighting a magnificent battle against that ultimate thermodynamic silence.
So what's the crucial takeaway from all this? The grand arc of life isn't just this simple timeline of birth, growth, and death. It's the miraculous rise of complexity.
It's the constant, incredibly demanding maintenance of criticality. And finally, it's the quiet settling of the system. Life truly is the art of remaining near the razor's edge. Which leaves us with a pretty wild final question to ponder. How well is your biological digital twin maintaining your balance today? Thanks so much for exploring this explainer with me. Catch you next time.